Hey everyone! In this video sequence, we are going to implement an interesting phenomena that's called rich getting richer phenomena. It's also called Matthew effect and it's also called preferential attachment. Now, there is a particular model that's called Barabasi-Albert Model, which is precisely based on this method that's called preferential attachment. So, we are going to implement Barabasi-Albert Model in the subsequent videos, and that'll be same as implementing rich getting richer phenomena as well. Before we get into the steps of implementation, let's look at the main idea behind this concept. So the main idea is that we're going to start with some m0 number of nodes, and these nodes are going to have some edges across each other. The only condition is that every node should have at least one edge. This means that we start with an existing network of m0 nodes, and the new nodes get attached to this existing network one by one. Now, how do they get attached? There are two properties that every node follows, and the first thing is that every node gets attached to some m number of existing nodes. So, for example, say m0 is equal to say 5 and m has to be less than equal to m0. So, assume m0 is equal to 5 and m is equal to say 3. So, we'll start with an existing network of 5 nodes and one new node will come and it will get attached to some 3 existing nodes, and then second node will come that will also get attached to the existing 3 nodes, and so on. So this keeps happening. Now, how do we decide which 3 existing nodes should get attached to the new node? That is decided by preferential attachment. Now, what is preferential attachment? This means that the more connected a node is, the more likely it is to receive links with the new node. In other words, more degree an existing node has, more probability it will have of connecting to the new node. So this is how we'll keep adding new nodes to the existing network. This was the main idea behind rich getting richer phenomena. Now let's look at the steps that we are going to follow for the implementation. So we're going to require the value of n, that is the total number of nodes in the network. We will take the value of n from the user. The other thing that we need is the value of m, that is equal to the number of edges that every new node is going to get attached to. Basically, the number of edges that every node will introduce into the network. So we can take the value of m from the user, or we can have our code decide the value of m automatically. In our code, we will decide the value of m based on n. It's up to you. You can do whatever you feel like. Okay, the other thing that we need is m0. As I told you, m0 is the number of nodes in the existing network, in the initial network. The only condition is that m should be less than equal to m0. So we need n, we need m, and we need m0. These 3 values we need, and the only condition is that m should be less than equal to m0. So in our code, we are going to have m is equal to m0 minus 1. You can just fixate on any value that you wish to have. So in our code, we'll have m0 to be any random number between 2 to n by 5. This is just an assumption that we are taking. You can go ahead with any value of m0. You can fix on a value m0 is equal to 4. So every time you will start with an initial network of 4 nodes. And m we will take to be m0 minus 1. You can take any value. Now we have a network of m0 nodes. The next step is to keep adding new nodes to this existing network. So the number of nodes that are going to be attached is equal to n minus m0, because n is the total number of nodes. So these n minus m0 nodes are going to be attached to the existing network based on preferential attachment, as I explained to you. Now let's see how we are going to implement preferential attachment. Okay, so we have to add n minus m0 nodes one by one. So firstly, we'll add the node to the network. The next step is to add m edges to this node, to the existing nodes in the network. Now, how are we going to decide the nodes that are going to be attached to this existing node? As I told you, we need the probabilities, okay, and the probabilities are going to be decided based on the degrees that the nodes have. More the degree, more the probability, right? So for that matter, we need to keep a track of the degrees of the nodes. So we'll do some pre-processing for this keeping track. We will maintain a dictionary of degrees for every node, because the degree is basically going to decide the probabilities. Second thing is we'll maintain a dictionary of probabilities. So probability of a node getting attached to a new node will be equal to the degree of that node divided by the sum of the degrees of all the nodes, right? So more the degree, more the probability. So we are going to maintain a track of the probabilities in a dictionary. Now, apart from that, we're going to maintain a third thing. We will basically maintain a list of lists, because we want to keep an order of the things, an order of nodes. Dictionary doesn't let you maintain an order, so we are preferring to keep a list of lists for maintaining cumulative node probabilities. Okay. Now, let me tell you why we need that. So whenever you have to choose a node based on a probability, this is the standard technique that we use, although you can devise some other method as well. We are going to follow this method of making use of cumulative probabilities. Now let me explain you what that is using an example. Assume there are 3 nodes and they have the probabilities 0.2, 0.3 and 0.5. We are going to maintain a list that is cumulative probabilities. So the first node will have cumulative probability 0.2, the second will have 0.2 plus 0.3, that is 0.5. The third will have 0.5 plus 0.5, that is 1.0. So this is a list that we are going to maintain. I'll show you how we are going to use this list. So the new node has come. We have to connect this new node to existing M nodes. For that, we will choose a random number between 0 and 1, okay? And then whichever node has cumulative probability more than this random number is actually the node which is going to be connected to the new node. Let me show you an example. So assume R comes out to be 0.4, okay? Let's look at the cumulative probabilities list that we just created. So first node's cumulative probability is 0.2. which is less than 0.4. So we will go ahead, we'll check the second one. 0.5 is the second value. 0.5 is more than 0.4. So we'll stop there. Since R is less than or equal to 0.5, the second node is basically the node which is going to get connected to the new node. You would have understood this method, but do you understand the main idea behind it? So the main idea is that more probability node has, more likely it will get connected to the node. This is what we have to implement. Now try to understand how this particular method is helping us implement the same thing. So basically, more probability a node has, more window it will have in the cumulative probabilities list. Now what do I mean by that? So as you can see, just take a look at the cumulative probabilities list. So we have first node's cumulative probability to be 0.2. So its window will be 0 to 0.2. The window for the second node is 0.2 to 0.5. Okay. The window for the third node is 0.5 to 1.0. Okay. So now you can see that the window for the third node is more than the window for the second node. And the window for the second node is more than the window for the first node. So more wide a window is, more likely it is that the random number is going to fall into that window. Okay. So assume a node has probability 0.1, its window will be 0.1 big. If a node has probability 0.6, its window will be 0.6 wide. And more likely it is that the random number is going to fall into that window. Okay. And that's precisely we are implementing here. So, if a node has more probability, the random number is going to fall into that window more likely, and that's how we will connect that node to the new node. So that's the main idea. This is how we are going to add the edges to the new node, and this is how we are going to add new nodes up to the point that we get total n nodes in the network. So this is the main idea. In fact, not the main idea, this is detailed steps of implementation that I've discussed with you. I would suggest you, since I've gone into detail into these steps of implementation, it will be nice if you just start off yourself, coding yourself and implement yourself, and don't follow the subsequent videos line by line, and just compare the results with the results of the subsequent videos. That'll be a nice practice. So let's get started with the coding part.